All right, we're gonna do a few questions just like we did yesterday. I honestly am not gonna spend the time because I don't think these are loaded up in this board yet. So at the top, it has our little brain dump 3, 60, 30, and 60, and 45. So, you know, never hurts to do these things. We got square root 3 over 2, 1/2, square root 2 over 2, square root 2 over 2, 1/2, square root 3 over 2.
There's one on the line too. Is that one like
The one down here, you're saying?
yeah,
Yeah, so that would be
0,
1, 0. And this would be 0, 1. This could be 0 degrees. They've also got our radians, and it's a little bit tight in there, so pi over 4, pi over 3, sure. I also like to cheat and put my tangents. Square root 3, 1, square root 3 over 3. Now the only thing that we did yesterday, and the only thing we're doing today, is expressions. Expressions is basically equations with no equal sign, which does actually limit you a little bit. If we have an equal sign, we actually get more powers. Like we can multiply everything by this, and we can do this to both sides. But with expressions, that's not really how it works. You just gotta simplify that fraction, simplify that number. And so the first one, we've got 12 cotangent of 45 minus cosecant 30 plus secant 45. Now, we want to see this as a trig piece, a trig piece, and a trig piece. And so we want to write this down as 12 times whatever that's going to be minus whatever that's going to be plus whatever that's going to be. And so now we're just going to use our unit circle, grab those 3 pieces, and we'll end up having to do a little bit of fraction stuff probably and get the answer. We did a nice warm up before we started, just grabbing this kind of stuff from our unit circle, and I started off today with a little bit of a pump question for you because all 3 of these are our reciprocal trig functions, the upside down trig functions. I'm going to start with my cosecant 30 because that's the easy one for me. I know that the cosecant of 30 is like the sine of 30, and I like the sine of 30. The sine of 30 is 1/2, so the cosecant is going to be 2, the upside down sine of 30. And so you can go whatever order you want and grab the ones you like and grab the ones you don't like. I also like the cotangent of 45 because the tangent of 45 is 1, and the upside down of that is just going to be 1. And the last thing I have there is the secant of 45. I don't think that's quite as nice. The cosine of 45 is square root 2 over 2, but I need to flip that upside down,
square root 2,
which is just square root 2. Because if you do flip it upside down, and you get 2 over square root 2, then you rationalize, then you're going to have 2 square root 2 over 2, cross off those 2's, and you're going to end up with just the square root 2. Here's a little bit of a aha moment, if that seems kind of random. Where does square root 2 over 2 come from? We made this using rationalization. We rationalized it. This answer actually started out as 1 over square root 2, and then we turned it into this.
Oh, yeah.
So if we go backwards, and then we flip it, that's why it ends up as a nice square root 2. So now for these expressions, we want to push together as much as we can, do the multiplication where we need. 12 times 1 is 12. 2, it's just a negative 2, it's going to stay. Square root 2, it's just a positive square root 2, it's going to stay. Combine what you can, and importantly, don't go crazy, right? If you've got fractions, adding means common denominators. If you've got regular numbers and radicals, you cannot add them together, but you can multiply them together. So you got to know your rules. Good news is it's rules from Algebra 1 and Algebra 2 and all those other classes. Final answer here is going to be 12 minus 2 is 10 plus square root 2. And that's as good as it gets. It can't get any nicer. It can't get any simpler. We can't smush them anymore together. We cannot simplify. We can't do anything at all. Final answer, 10 plus square root 2. Honestly, the hardest thing that we do today might just be feeling like, am I done yet? Or do I need to simplify this a little more? That might be the hardest thing that we do. Okay, keeping it moving because I feel like we're doing really well and no reason to slow it down. Tangent of 13 pi fourths minus secant pi. Pi, please. Okay, cool. Now this has no coefficients, so this is just going to be whatever that is minus whatever that is. The secant of pi is a quadrantal. Pi is the one all the way over here, which is at -1, 0. And the secant is the cosine x upside down. So it's the -1 upside down, which is still -1. The tangent of 13 pi fourths, well, I know it's a fourths, so I know it's a 45 family. So what's the number going to be? 1. Is it going to be a positive one or a negative one? You can do your spatial lap type stuff, or you can do your subtract 8. So maybe it seems like in class, the people who are allowed like to say, I say that positively, the people who respond to me when I ask. So we got 5 pi fourths, and 5 pi fourths is just a little bit more than 1. It's in that quadrant 3, and so this is going to be positive. So we have 1, oh, not what I said. There we go. We have 1 minus -1, final answer, 2.
Yep.
That one's pretty, okay, we know we're done, 2. Next time somebody asks you, like, you know, hey, what time you want to meet up this weekend? You know, just tell them, what about tangent of 13 pi fourths minus secant pi?
Yeah.
2 o'clock. What's it? 2 o'clock. What are you guys talking about? 2 o'clock. You guys don't want to hang out 2 o'clock? All right. Fair enough. People love being friends with math. All right. Well, this one again, no coefficients. All we gotta do is multiply 2 numbers together. That's not too bad. Unfortunately, we're starting off with negatives for both of these, which is kind of gross. And this half is going to be a quadrantal. So, you know, maybe I do -5 pi halves plus 4 pi halves. Honestly, that's not even going to be enough. So maybe I do plus 8 pi halves. A little shortcut, because 8 pi halves will be 2 full laps. So I'm going to get 3 pi halves. 3 pi halves is down here, 0, -1. Cosecant is the sine, which is the y value upside down. I got -1. Okay, the secant of -11 pi sixths.
Wait,
What up?
well, you did -5 pi plus 8.
So you can do 4 pi halves, because that's
So
2
you
laps.
do it again.
Right. I knew that if I added 4, I was still gonna get -1. So I just said, well, instead of doing 4, I'll just do 8 all at once. Yeah. So you could also add 12, because that would be 3 laps. Or you could add 16, because that would be 4 laps. It's just coterminal. It's like how we're starting to use 720 every now and then.
Yeah.
It's the same thing. This 11 negative is a little bit easy spatially to recognize that it's in the first quadrant. It's a 30. It's going to be 2 square root 3 over 2. Or no, over 3. Ooh. Almost dropped the ball there. I know that my cosine of 30 is kind of the ugly one, square root 3 over 2 when I flip it upside down, and then I rationalize it. Final answer, okay, it's just a negative, so negative. And we got one more question, then we're done for the day. As far as those go. Then we just got 100 questions for homework and we'll be done. Secant of 0 squared plus the cotangent of 30 squared times cosecant of 60 squared. Alright, my handwriting is horrible, but I did notice that we have a plus in this position, but no plus in between these two, which means it's a multiply. So don't, make sure you kind of read it carefully. 0 degrees, well, that's kind of easy to find. It's right here at 1 comma 0. And the secant is the x upside down, which is 1 squared, plus the cotangent of 30. Well, again, I kind of cheat and I know my tangent values are like this. Cotangent of 30 is going to be this one upside down, but that is going to make it end up looking actually like that one. Square root 3 squared. Now I kind of like that squared because that squared is going to get rid of my square root. So that's actually working kind of nice. And then the cosecant of 60, well, I know that my cosecant, which is like sine, I know that my sine likes the number 30 because the sine of 30 is 1/2. This is unfortunately not the same thing. This is the cosecant of 60. So I need the square root 3 over 2 upside down. So I need 2 square root 3 over 3, the ugliest version of anything. Squared. All right, we'll pause for just a second. Secant of 0, that wasn't bad really. Cotangent of 30 is just like the tangent of 60. And then the secant of 60, well, the sine of 60 squared 3 over 2, upside down. 2 square root 3 over 3. Now let's handle these squares next because we know PEMDAS, parentheses, exponents. Exponents comes next, so that's going to be 1 squared, 1, plus square root of 3 squared, 3. Multiply that by 2 square root 3 over 3 squared.
2/3. I thought it was
It's
2.
not quite
I
2/3.
thought it was 2.
It's not 2 either.
Is it a over or a fraction?
It is a fraction. So, when you square something, and it's a fraction, you just square the top and you square the bottom. Okay? So, if we go to square the top, 2 square root 3 over 3 squared, which is multiplied by the same thing. On the top, 2 times 2 makes 4. Square root 3 times square root 3. Square root of 9, which is 3, like you said. And on the bottom, 3 times 3
It's not.
9. So we're getting 4 times 3 divided by 9. And we know that 3 and 9 can reduce, and we get 4/3. Now, that's a totally fine thing to do. Honestly, it's a little bit much, okay? So here's where you can kind of level up, right? This is honestly where the kids, oh man, why do you make this seem so easy? This is the level that those teachers and students are on, okay? Imagine this. This piece, which is 2 square root 3 over 3, it looks like that because we rationalized it, right? That's why it's got that square root 3 on the top and that 3 on the bottom. It would be easier if we unrationalized it. Instead of thinking about it how it is, what if we unrationalized it for just a second? Now, when we square it, What's 2 squared?
4.
And what's square root of 3 squared? Done. Okay? So actually, the pro gamer move a little bit is, okay, sometimes it might work better if you think about unrationalizing it, right? If you think back to this question, the secant of 45, which is square root 2 over 2 upside down. Well, if you think about unrationalize it, now flip it, you just get square root 2. Right? It's a little bit of a shortcut. And again, you don't have to do it, but it is a shortcut. It is nice. Well, when we do that, this question ends up finishing pretty nice because we have a times 3 and a divide by 3. And so we get 1 plus 4. So we get 5. Alright, listen, we are gonna have lunch in about 8 tangent 45 minutes.
Get out. Get out.
The tangent 45 is one, come on.